Okay, the next topic in Chapter 3 is atomic structure. And what we mean by that is, what does the atom look like and what is in it? So if we start, there is a very small, dense region containing most of the mass, in fact almost all of the mass of the atom, and this is called the nucleus. And the nucleus contains the protons and the neutrons. The protons have a positive charge and the neutrons have no charge. And both of these particles have about the same mass, 1 AMU, which means atomic mass unit. They're slightly different, but for all purposes, we're going to say they're 1 AMU. Okay, now this is surrounded by most of the volume of the atom. Consists of these energy levels that contain sublevels, but this whole structure is called the electron cloud. And the electron cloud contains the electrons. And the electrons have a negative charge and the electrons have no mass. They have a very small mass, but for most of our purposes, if we assume these are 1 AMU, then the electrons have no mass. So it means all of the mass is located in the nucleus. Alright, so if we have a neutral atom, then we have the same number of protons as we do electrons. And if we look at the periodic table, it is arranged according to atomic number. So these whole numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, those whole numbers are the atomic number. And the atomic number is telling us the number of protons. And if it's a neutral atom, meaning if it doesn't have a charge, then we know that's the same number as the electrons. So if I happen to look at, let's say, nitrogen, its atomic number is 7, so therefore it would have 7 protons and 7 electrons. Now, a special kind of an atom is an ion. And an ion is a charged atom. This means the number of protons is not equal to the number of electrons. Alright, so we said if it was neutral for nitrogen, had 7 protons, meaning 7 positive charges, and it had 7 electrons. So that means it has 7 negative charges. So 7 positives and 7 negatives means no charge. However, let's say that we have nitrogen, which means 7 protons, but now, that's 7 positives, now let's say that it has 8 electrons. So that means it gained an electron. So that means 8 negatives. So 7 positives with 1 negative means a negative 1 charge. And that has a charge, so that is an ion. And since it's a negative 1, we call it an anion. Now if we have nitrogen, we said it had to have 7 protons. And let's say now it lost an electron, so it has 6 electrons. So now I have 7 positives and 6 negatives, so I have a positive charge. And since it's positive, it's called a cation. That little T in there makes you think of a plus sign, which is a positively charged. Alright, so let's say that we have something that has, we'll say, an atomic number of 14. So it has 14 protons, and then let's say that it has 16 electrons. Okay, so if it has 14 positives and 16 negatives, then that means it has a -2 charge. And if it has 14 protons, I know what element it is. So I look up here, 14 is silicon. So I would write this as silicon with a +2 charge. So I write that as a superscript. Okay, so the charge is written up above here, and that's the charge of the protons and the electrons together. And the protons is the atomic number, which tells you what element it is. Okay, now we have a different kind of an atom. And this is called an isotope. And an isotope is an atom with a different mass, which means it has a different number of neutrons. Okay, so the average atomic mass is the number that's on the table. So this is the decimal number on the table. And this is the weighted average of all the isotopes of that element. Okay, and because it's an average, it doesn't come out to be a whole number. It comes out to be a decimal number. Okay, so when we look at the periodic table, like for carbon, 12.011, that is the average mass of the different isotopes of carbon. And for oxygen, this 15.999, that is the average mass. So just like if you would take maybe 3 humans, and we would weigh them and get an average mass, each one of them is a little bit different, but we would come up with an average. So each element has its average mass, and that's made up of these different isotopes. So for example, carbon has 3 isotopes. There's carbon 12, carbon 13, and carbon 14. Carbon 14 is the one that you hear about for isotopic dating. Now, all of these are carbon, which means they have 6 protons. Okay, and if these are neutral, then that means they would all have 6 electrons. Okay, but this is telling me the mass. And remember, the mass is the protons and the neutrons. So this is the mass number. That's the number of protons plus the number of neutrons. So if it has a mass of 12 and 6 are protons, that's 6 neutrons. If it has a mass of 13 and 6 are protons, then we have 7 neutrons. And this would be 8. So they have a different number of neutrons, meaning I have 3 different masses. One with a mass of 12, one with a mass of 13, one with a mass of 14. And these 3 are all isotopes. So they average all those isotopes together, and they get the average mass of a carbon atom. And that's what's on the periodic table, is the average mass. And then the symbol and the atomic number is always the same. Alright, now in order for us to figure out our average atomic mass, we have to do a weighted average. Okay, and they have to give us 2 pieces of information. They have to give us the masses and the percent abundance. Okay, so to calculate our average atomic mass. So let's say that they say I have 2 isotopes. We'll say we have chlorine 35 and chlorine 37. The 35 has an actual mass of 34.97, and this is 36.97 atomic mass units. Okay, in addition, they're going to give me the percent abundance. So it means if I would dig up a sample, in this case, 75.76% is the isotope that's chlorine-35. The other percentage, the rest of it, is the chlorine-37. Now, we're not going to do a straight average, so we're not going to add those up and divide by 2. We're doing a weighted average, which means this one is more abundant, so the average mass is going to be closer to this 35. Okay, so I'm going to multiply my percentage times my AMUs. Then I'm going to add those two numbers together. I get 3545.48. Now, usually when I multiply by a percent, I take it and I divide by 100, but I'm going to do that at the end. So I multiply by the full percent, but then I'm going to divide by 100 when I get to the end. So I'm going to call this 35.45. And since these all have 2 decimal places, I'm going to round that last one to 2 decimal places. So between 34.97 and 36.97, the weighted average is 35.45. Okay, so you take the percent times the mass, percent times the mass, and then add them up. I don't divide by 2 or anything else. I just divide by 100 when I get done. But I'm not going to divide by how many I have. If I had 3 isotopes, it would be the same process. I would just do that for the third isotope. Percent times mass, add those 3 up, don't divide by 3, divide by 100, and then label your answer AMUs.